All right. So now, before we were just like taking these around a line so they'd be one solid object. Now they're going to be like a washer, and we're going to go all the way around the x-axis. So this thing would look like this, and like a 3D model of it would look like this. Well, it's thicker on one end than the other. So this should be more of a straight line. So that's what it would look like. Yes, it's a really thick washer. It's more like a bushing than a washer, okay? If we want to get down to brass tacks. So the washer method formula is a lot like the other formula, the disk method formula, but it's pi, the integral from the first x to the last x of r squared of the big or the far radius minus r squared of the near radius d whatever x or dy. Okay, so since we're going around the x-axis on this, okay, since we're going around the x-axis, you know, the pi is on the inside, but we always take it to the outside. The integral of the x's used, so we go from 1 to 4 because we have little things along here, okay? So you understand we're going from 1 to 4. The further out away one is the square root of x, and we're squaring it. The nearer one is 1, and we're squaring it, dx. Okay? So it's pi times the integral from 1 to 4 of x minus 1 dx. So we just grab our handy-dandy graphing calculator and go on. We go math 9. Get our integral from 1 to 4 of x minus 1 dx, and you get an answer of 4.5, and you say, I want a fraction, please. And it's 9/2, so exact answer in terms of pi is 9 pi over 2. Easy peasy lemon squeezy, right? That was easy.
Yeah.
Around the x-axis is easy. Dun dun dun. Now we go around the y-axis. So we need to have things like the bars like this, and bars that go all the way up to this, and then subtract them, type of thing. Okay? So if our bars are going that way, each of these needs to be solved for x. So what is our blue line going to have the equation of? X equals y over 2. What is our red line going to have the equation of? So it's going to be 2y, so it's going to be the square root of 2y. Because you multiply by 2 and then take the square root. Okay? So, which one is further away from the y-axis? The red one. So we go what numbers? 0 to 4 or 0 to 8? 0 to 8, because you're going along the y-axis. So it's 0 to 8 of the square root of 2y squared minus y over 2 squared dy. So it's pi from 0 to 8 of 2y minus 1/4 y squared, or y squared over 4 dy. So I would bet on the test you'd have to do this by hand, at least one of these by hand. Okay, not on the calculator. We're just saving time by using the calculator. Math 9, 0 to 8 of 2y minus 1/4 y squared dy. And obviously I change all my y's to x's. Do the math and say, calculator, turn that into a fraction, please. I get 64 pi over 3. Okay, let's do one more. Where are we going to go around? The y-axis. Because if we went around the x-axis, what method would we use? The disk method, because it's flush to the x-axis. It's touching it, so there's nothing to subtract. But since there's a gap in the middle, when there's a gap in the middle of where you are and what you're rotating around, it becomes a washer. And actually, this does not become a washer. It becomes a bowl when you rotate around the y-axis. It actually becomes a bowl. But there's an empty spot in the middle, so we use the washer method. So it's pi integral from what to what? 0 to 2 or 0 to 4? 0 to 4. What's a further one away? Is that y equals 2? Or that's x equals 2? And yes, the idea is correct. It's x equals 2 because it has to be in terms of x equals minus the closer one, square root of y squared dy. So it's pi integral from 0 to 4 of 4 minus y dy, which is pi. If we integrate it, it's 4y minus 1/2 y squared from 0 to 4. So we stick in the 4, we get 16 minus 1/2 of 16 minus 0 and 1/2 of 0. So those just basically disappear. 16 minus 1/2 of 16 is 8. So we get 8 pi. No calculator needed. Okay. Can you handle that? 4 problems like that? We're doing that before lunch. After lunch, we'll do it around non-x-axis. So